This week on Let's Make It, we are going to show you how simple it is to communicate between two different Arduino boards using Zigbee. And we're going to remote control a servo. Fun, fun, fun. All that and more coming up. Let's Make It is brought to you by Ting, the new way everyone is getting their cell service. No overage penalties, great rates, keep what you do not use, no contracts, and someone will actually pick up the phone when you need support. Use our link and get $25 off your first month's service or your new phone. Just go to tech-zen.tv/ting to save $25. Hello and welcome to another episode of Let's Make It. And as I said last week, I'm actually not here tonight. This is not live. It is Memorex. For those of you who are old enough to remember what Memorex is, I know I am. So last week we introduced you to Zigbee, showed you how to download software and stuff like that. And this week we said we're going to actually put it to use, and I have it here. This is been pre-recorded, so there's nobody here. If you're in the chat room, chat with other people, that's fine, but I definitely won't be around. I'm completely out of communication for this week. It should be released though at normal time. My wife is around and she's going to release it. All the YouTube stuff is manual still, but all the podcast and the webpage and everything is all automatic. It just comes online when it's available. It's scheduled to do so. So this week what I'm going to do is I'm going to take what we took last week and also what we did in episode 12. This is episode 14. Episode 12, we did a servo project, and I'm going to take the exact same software or sketch that I did for the servo project, and I'm going to use it in this project. And basically what I'm going to do, first of all, let me go show you what I have as far as the setup goes for the Arduinos. So let me go and show you that. So here's the Arduinos. I have two of them. We have a transmitter and a receiver. Actually, they're transceivers, the one's not talking back. On the right, here's the project from 2 weeks ago where we had the servo. I did put some different color wires in there because I unplugged it and then said I want to use it again. So it's going to sit here, and you can see these two are not attached in any way. This is a USB cord right here that's just giving it power. And on this side, I have another Zigbee. You see on top the Zigbee shield right here and the Zigbee unit, and which we showed you last week, and they're now attached to the shields. And in this side is a Zigbee shield, and these are both Arduino Unos on the bottom. And on this side I have two switches. So I have, my pins are coming out. I have switch 1 and switch 2, and these will control what the servo does. So I'll very quickly show you that if I hit button 1, servo goes to a position. If I hit button 2, servo goes to a position. And this is all done via Zigbee. So me pressing these buttons is telling it where to go. And I'm going to walk through this code. This code is actually very simple. When you see how simple it is, it's a little bit scary. The most complicated part is what we covered last week. And let me just say that I still continue to have issues with Zigbee units, trying to figure them out. I think I'm going to have to learn the API mode to get it to work properly. And I mentioned last week also about the broadcast mode, which is how this is working. So this one is broadcasting on this channel to any Zigbee that's listening. So I could have a whole bunch of these sitting around, and they're all going to do the same thing whenever I press the buttons to go back and forth. You see, it's really quick too. I am using the default 9600 baud. I could increase that speed, but I'm basically sending across a number like we did before. We typed it in before. If you go back and look and watch episode 12, we had it set up so that in the serial monitor we could go type in a number, and the servo would go to whatever number we put it based on the angle that we sent it. So all this is doing is it's sending across a number depending on which button that I press, and I'm going to show you how we can change that number. But that is how simple the project is today. But it's to demonstrate the wireless between here and here. And when I show you the code, I literally didn't make any changes to this code. It is exactly as it was before. This Zigbee unit, or the xbee unit, is simulating exactly what I did before as far as typing in the serial port. It's the exact same speed, and it's sending the exact same data. So that program did not need to be changed. So if you have episode 12 somewhere and you get one of these xbee shields, and you get another Arduino and an xbee shield, you could do this exact same thing using that same code you have from episode number 12. So that is the setup that we are looking at today. So let me go ahead here. I'm going to get I haven't done this yet. Let me get my computer up so I can switch to it. All right, there it is. And I'm actually going to go and I'm going to show you the servo position. So I'll walk through it real quickly, not in any great detail. I would just recommend going back to episode 12. The code's there and everything as well. And let's go quickly, maybe maximize this so we can see it. I'm going to switch over to it. All right. So let's go back to the top. So this is exactly what we did in episode 12. Comments to the top. Basically, we're just including servo, defining a servo, defining a variable to read in what we're getting through the serial port, and the loop to read that in the current value. Our safety max value is in here. I do serial begin at 9600, and I attach the servo to pin 9. And I go into the loop and I read in characters from the serial port until I get something that's not a number. At that point, I assume it's the end of the line. Then I come in, and at the end of the line, I basically terminate the string, take it, convert it to a long integer, make sure it's within the safety range of the servo itself, and reset the read array back to 0. I'm still outputting to the serial port, although there's no need to do this. I could comment this out. That was just more for demonstration purposes, but it's not hurting anything either. And then I set the servo, and then I delay. So there has not been one change to this code from then. So this xbee shield is actually simulating me typing in at 9600 baud the number that I wanted to go to, like we did in episode 12. It's just reading it in. I mean, it literally is the same thing as me typing it in. That is how easy these xbees are. The hardest part of the xbee is last week's getting it set up. Now, there are some other options we can do that aren't as simple as sending text from end to end, and it's the API mode. And I'm not going to go into great detail with that right now. I don't even know exactly. I mean, I've read it, and I kind of get the concept of it, but I haven't done any experimenting with it, so I don't know how well that it works. For what we've been doing with our one project, this is exactly how we're doing it. We're doing a different speed than this, and we also have a little bit of protection in there for the network itself, as far as the key values and everything. But in basic form, this is exactly how we're doing it. Now, here is the disadvantage to doing it the way that I'm doing it here, is it's in broadcast mode. Broadcast mode does not retransmit, so that's a problem. It does not use the mesh features of Zigbee, which is one of the great things about Zigbee is the mesh. Now, in our particular project, that could be a problem in the long run, but right now we are consistently sending out a stream of data. So if your packet doesn't make it, it's likely going to make it the next time around. But there is a range limit. There's no meshing. So that is a problem that we're thinking about how to deal with. And it ends up being, if you don't do broadcast, you got to do some kind of management of devices. And if you don't want to take input from a keyboard, you got to somehow make it automatic. And it's a whole protocol thing that we're working out right now. All right, so that is the servo. So let's go out of the servo, because like I said, nothing really changed in there. And don't save, I didn't change anything. Now we're back into the transmit side, and this is very simple as well. It's actually simpler than what the servo side is. So let's go down past my comments here. And actually, I'll comment this better before I stick it on the website. But I basically defined two buttons, button 1 and button 2, and they are on pins 9 and 10. And then I have a value for each button. So button 1's value is 20, button 2 value is 165, and we have a two-state table, and that's what's called current mode. So current mode is either 1 or 2, depending on what button was last pushed, and you'll see why I do that. We come down to the setup, and we begin the serial port at 9600 baud. This has to be the same on both sides. That's something to remember. If it's not, it won't work. We set pin mode for button 1 as an input pull up, and pin mode for button number 2 is an input pull up. And what happens with the buttons is they take it to ground. So whenever it goes to ground, we see that the value comes down. All right, so we come down here, and we have this buffer value, which we'll use later, and I'll explain why I did that. And then we come down and we say, if the digital read of button 1 is not, which means, so by default, if the button is not pressed, digital read is going to come back as true. So what we want to say is if it's not true, which means the button has been pressed and pulled to 0, the voltage 0, and the current mode is not 1, so it's the current mode is 2, then I want to print to the buffer the value that is in button 1 value, and then I'm going to serial print that out, change the current mode to 1, and then I'm going to delay half of a second. And this is mainly for button bounce. I could make this a little bit shorter probably, but it wouldn't really matter in this case. After I did this, I thought, well, it didn't even matter because if 1 is pressed again, it won't do this again because it's already in that mode. So we set the mode. So you could really take out these delays. So I didn't have a chance to take them out because of all the other issues I've been having with it. So let's talk about this sprintf, which is string printf, to this buffer value. If I would send out, there's a couple ways I could do this. I could actually come up here and change these values to be strings or chars with a value of 20 or 165 and send them out exactly as they are. But if I'm trying to do something programmatically to add values or increase values by a certain amount, then you wouldn't be able to do that with strings. So I may even, during the show, since I didn't have time to do it before I got here, rewrite this to sweep back and forth, left and right, the Servo remote control. And I may do that live here on the air. It's actually something that's very quick to do. So that's why I did this. So basically what this is doing is it's saying, I'm going to print to this buffer, this character string buff, the %d, which is the decimal value of this, and then I'm going to put an X at the end. And if you remember from episode 12, the reason for the X is the other program keeps reading until it sees a non-numeric number. So in my experimenting with this, I tried just doing a serial print line. That sends a character turn line feed, which confuses the other side. So I ended up going back to just doing adding an X to the end of it. It could be any value other than 0 through 9, and this will work just fine. So this value then equals the number at the top and serial print buff. And then I set the current mode. So basically what that's saying is I'm now in the button 1 mode. So if I see button 1 again, don't do anything. There's no reason to send it over because it already knows on the other side what it is. And then I delay half a second. Again, this could be taken out and it wouldn't hurt anything with the state this is working in. And then we do the same thing with button 2. If button 2 is pressed and button 2 wasn't the last thing that was pressed, we're going to take the value of button 2, send it out with an X on the end of it, and change the mode and wait half a second. That is the end of the program. Very, very simple. So let's go up to the top. So when I press button 1 and you see it sweep to a position, it's going to basically, I'm going to call it degree 20. If we look at it as in degrees. And if I press button 2, it's going to go to 165 degrees, which is, so you see it going back and forth. I have determined that this servo's maximum is about 176, so it's going pretty close, a little bit back from each end by me pressing each of these values. So that is really how simple it is to send things over Zigbee. The hard part is configuring the Zigbee itself. Now, if you were writing a program to take any Zigbee chip and plug it in and let it work, you would have to write all the AT commands that we went through last week in the setup to get it to work right. So you can't assume that what you have is configured properly when you first start running. So you should go through and do all the AT commands that you know to get it all configured properly. And that's something that I didn't do in here. It's already configured. So that's something we could add maybe in a future episode, but we went through the AT commands last week. If you think about it, it's actually not difficult to do. And if I get time, I may even put something in the show notes about how to do that as well. So that way you know what you're getting. In my case, I have one central location that's sending out to all of the clients basically. So I have one controller and I have a bunch of clients. And the controller code, I actually do the AT commands to put it into controller mode. These particular chips I'm using do not require a special load to be the controller. It's just setting a value in the AT commands. However, some Zigbee units do have special firmware you have to load to be the controller. So you have to think about that a little bit and look at what you have. I don't know if, I think mine are version 2s, maybe all version 2s are like this, I don't know, but if you read through books about it or places on the website, on the internet about it, they're going to tell you that you have to change the load, basically put different firmware on the chip to make it the controller. And these don't have to do that. So my central system will come up, put it into controller mode, does all the setup on the AT. Every time it turns on, it does that because it doesn't know if something's changed since the last one. And the clients do the exact same thing. Now, right now, because I'm in broadcast one-to-many mode, which is not as reliable, and I'm looking to change that. I want to use the features of Zigbee to make it resilient. So this episode went really fast because I kind of had it all set up, and then the code is so simple to do this. I spent so much more time getting the Zigbee to work, and as I told you last week, I started the recording late because I think I actually ruined one by static electricity, and I was fighting with it trying to figure out what I was doing wrong, and I got another one that worked right off. So that was part of that. Since I got so much time, and this was so quick of a episode, I am going to go in and I'm going to change this program to have the buttons do a sweep. So I'm going to go over, I'm going to do a save as and create a brand new program, and we're going to walk through and we're going to make one that the buttons go sweep up and down. So let me switch over to the computer, and let me go up here and I'm going to do a save as. And this is going to be, I'm just going to call it button sweep. I'm not going to worry about the comments. I'll change the comments before I send it up there. So we're going to do this. We're actually going to say min value and max value. And in my case of the servo, 176 is my max. I'm going to make it 175 just to be safe. And then I'm going to do one it's the current value. And I'm going to set it to 1. And I'm not going to need current mode for this particular instance. All right, so everything else there is the same. So here I'm going to read button 1. I don't care what the current mode is because we don't have a current mode anymore. So I can get rid of this. And get rid of current mode here. And actually I'm going to leave the delay in. I'm going to make it a little bit shorter. I'm going to make it like 200 milliseconds. The reason for that is these arduinos are pretty fast, and if you have the button held too long, it's going to sweep really, really fast. Actually, I'm probably not going to, I'm just going to go to 50 and see what it does. We'll may have to adjust this. That would allow you to do 20 a second. I think that's probably pretty decent. All right, so if we're pressing button 1 is going to be the up value. So we are going to add to current value. So I'm just going to copy this and make sure I spelled it exactly the same. Just like this. And we're going to check if current value is greater than max value. We're just going to say current value is equal to max value. And then we're going to do current value right here. And that will do that one. Now down here we're going to reverse this. So I'm just going to copy this and change it to be a little quicker. So I'm going to copy, and instead of adding, we're going to subtract. And if the current value is less than min value, actually I think max value, yeah, this is why I copy things. Just so the case is the same. Messed that up. Let's fix that real quick. All right, and then min value, if it's less than the minimum value, we're going to say it's the min value, and current value. All right, let's just check it to make sure it's okay. Now, here comes the question of which Arduino is it? Let me unplug the one I don't want to do just to make sure. Let's unplug it from the computer. Okay, so the only Arduino that's plugged in. Now here's the other trick about the Arduino. Let me go to the Arduino and show you. I don't know if you can see it, it's too far away probably. But these little blue pins here, if I want to program the Arduino, the pins I mentioned last week go from the serial port on the Arduino to being the USB. I have to unplug these, otherwise I cannot program it. So the other option you have is to take the shield off, but this is actually a little easier than taking the shield off. All right, so let me go see. Let's go back over to the computer here and see what serial port I have. It's already selected. Let me go ahead and push this up. All right, it's uploaded. Now, one thing I should probably have done, which I didn't do, and we'll see if this works right off the first time. I'm not going to go fix it, but I didn't send out the default position. So what I probably should do is in the setup mode, I should do this, send the current value out so that the servo goes to value of 1. But in this case, I'm not going to worry about it. Let's go over to the Arduino and let's see how lucky I got for the first time. All right, we're going to go up. Well, that's being unlucky. So let's do this. Oh, helps to plug in the other Arduino. All right, so we're going to go up. Still being unlucky. There it goes. So you can see it's going up. I can probably lower the delay down a little bit. That's up. That's down. So let me go in. I'm going to change the delay to 20 milliseconds and we'll see what happens. All right, I changed the delay. Let's go here. I'll show you what I did. I just changed the delay right here. I tried to keep rest to 20 milliseconds. And now I'm going to go unplug the little blue things, the little blue jumpers, because I'm already on the right Arduino since I unplugged the other one before. All right, now let's go re-upload. All right, done uploading. And I'm putting the little blue jumpers back on. Let's go back over to the Arduino. All right, so I got one more jumper to go. All right, so now we're going to go up. They could probably, I went up pretty good there. All right, that's a little weird. I don't know exactly what it's doing. Let me go look here. I'm not exactly sure. I am sending out numbers. I'm wondering if I'm sending it out too fast. I never ran into this problem before. So let me do this. I'm going to reset both Arduinos. Oops. Well, I'll get this. I want to turn this off. Well, maybe that 20 milliseconds isn't a good thing. Wow, do I have something to tell you about today, man? Wow. I mean, you guys, you get tired of your cell phone service? You know, I mean, I just had an overage. I mean, it was horrible because I went and got my data coverage. I went over to my data coverage. And man, it was just beat me up over that. But I have some good news today. I want to tell you about Ting. Ting is the new way of doing cell phone service. And it comes from somebody who's very familiar to almost everybody. You've almost all heard of Tucal's and that is who he runs Ting. And they got some great rates. I mean, if you look at the plans, and they're a use what you pay for what you use type of service, where if you don't use the $500 minutes a month that you paid for, $9 for, and you've only used 100 minutes of it, they will drop you down to the next level, which is $3 for the 100 minutes. Would your cell phone service actually take and drop your rate because you didn't use all the minutes that you bought? No. This is the first company I've ever heard. It's a whole new way of doing business. And let's look here. Let's look at some of these rates. 500 minutes a month. If you're using 500 minutes a month, it's $9. So I don't even use close to 500 minutes a month. So I'd be $9 for the phone service. I don't do that many text messages. Let's say I'd be at most 100. So that's $3 a month. And let's say I do a gigabyte a month in data. So that's $24. So my total bill through Ting is $42 a month. And if I don't use that much data, it'll drop the price. And if I use more, it just brings the price up to the next tier. It's all completely automatic, which is awesome. No company's ever done this before that I've ever heard of. They always want to take your money and charge you overage fees. And if you do go over, there's no fee. You just pay for the extra usage that you use for that month. There's no fine for going over and using the service. It doesn't make any sense to be able to fine you for that. So yeah, they have great rates. Plans starting as low as $9 a month, and I mean really $9 a month. That's for 100 minutes a month. So you could get the cheap phone for your kids for emergencies or for your grandparents or whatever. No overage payments. Like I said, there is no more fear. There's no anger, and there's no suspicion or worry about it. You're going to go over that made-up limit that your current provider has given you. And then when you know you've gone over it, you wait for that heavy bill to come every month, and you're holding it like it's a bomb getting ready to go off before you open it up. And if you don't use it all, like I said, you get credit back. You don't use what you thought you would, they'll drop you down the next tier, and you won't pay that much for that month. And that's revolutionary. There's no carrier I've ever heard of that's done this before. It's awesome. You can put multiple devices on one plan. I mean, how many plans did your family have? Most families have 2 to 3 plans, cell phone plans, and they're not like a family plan. With Ting, it's real easy. You add a phone, you just pop it on the plan, and it comes right up. And starts working right away. And you can actually go out into the dashboard and understand how your family is using the service too. Are they getting close to going over the minutes? Do you want to get a better price for your minutes, go up to the next tier? Do you want to drop certain things down? You can watch how everything's going in nice, easy to understand graphs right on the dashboard. It's great. There is, like I said, there's no fees or limits on usage. So let's say you have a carrier and you have unlimited minutes, and now you've gone over the 2 gigabyte limit, and they're going to start slowing you down. You have to worry about that here. There is none of that here. Ting allows you to use all that you want. There is no limitations and no additional fees for that. Tons of free features too. I mean, it does not make any sense. These other carriers are charging you for your data. Then they want to charge you to tether your phone. Why? It's your data. You're going to use it after all, right? So it doesn't make sense. With Ting, there is no additional charges. There's free tethering, free hotspotting, free number porting in either direction, in or out. If you want to leave Ting, they'll gladly help you get to the carrier you want to go to. Free picture and video messaging. All that's normal call services, call forwarding, call waiting, voicemail, all that's included in Ting. And get this, there is no contracts. What would you do if you left your current carrier right now? Are you under contract? Would you have to pay a penalty to get out? With Ting, there are no contracts. So you can cancel at any time without any penalty. You can bring your own device or buy one from Ting. They'll work with you however. They're very flexible. You do whatever you want. No problem. And think about this. I mentioned before about the $9 a month. Think about strategically used devices. For example, your mother who doesn't normally use a cell phone and getting up there in years, you want to stick one in the glove box in case she breaks down somewhere. $9 a month. That is great insurance for having your family be able to get in touch. And that's 100 minutes a month. I mean, if you don't use the 100 minutes, it's even less than it. It goes down to 0. So if it's not used, I mean, it's a great way to keep a device around that is easily usable. So yeah, it's great. They bring you can bring your own device, like I said, and they have great devices to buy. They have a lot of devices. Let's go take a look at what we have for the devices. You'll see very modern devices, lots of Android out here. There's Samsung, LG, all the big names are out here. There's more Samsung. There's a Samsung S3, the most popular Android phone on the market. And you can get the S3 in multiple colors and multiple sizes right here in Ting. And you buy the phone and it's your phone. There is no contract to worry about. And for those strategic phones like I was talking about, here are phones that are really cheap, Samsung phones that you can use in the glove box for emergencies. Just keep them charged every once in a while. And I mean, they're really inexpensive. And you can also get your wireless devices for data as well, right from Ting directly. So there's also, they have something else that I've never heard of before, and it's the no hold customer support. Monday through Friday from 8 a.m. to 8 p.m., there is no hold. They turn hold off. So when you call, it rings until somebody picks it up. There is no going into the queue or anything like that. And they pick it up fast too. And their support staff, they're empowered. They don't have to go to the supervisor to get things. They give you the real name, none of these made up names. They actually all post in their pictures and everything, and they post to blogs. They're kind of, the way they describe themselves is like you have that person in your family who comes and fixes your computer, your nephew or whatever. They hire people like that already know how to use the phones, and they just train them on the Ting way. It's awesome. I mean, they're already up to speed, super smart, and no hold. There is none of this waiting in the queues and pressing numbers, and it's just immediately ready to a person. They're all empowered to fix your issue. There's those clear, easy to read graphs on the usage on the page, easy to understand bills, cancel anytime, and as you saw on the phones, they are very Android friendly. The operating system that's the most popular operating system right now in the world, Android, and they embrace Android. And their coverage is awesome. You should go to their site and check out their coverage and see what you can get. They use other major carriers to provide the service. So it's not like they're building out their own network. They are already there. There's nothing new to build out. They probably cover you everywhere you go right now. And I definitely recommend you go out and check them out. Now, we have a special offer for you from Ting, from techzen.tv. You can get $25 off your first bill, or $25 off your phone if you buy the phone from Ting. And the way you get that is you go to tech-zen.tv/Ting, and you'll go right to the special page just for us and get $25 off of your first bill or the device that you buy. And that's all just for listening to us. So, and that was something, appreciate Ting supporting us here. And I definitely recommend you go check them out. This is the way of the future, the new way to do cell phone service. All right, so apparently at 20 milliseconds at 9600 pod, I was a little bit overrunning the xbee and didn't like that. So that's something I have to consider in the future as well. And they can go up to 115, 200. I don't know what the actual bandwidth of xbee is. I don't think it's quite that high. But so now I'm at 30 milliseconds, and you can see that the servo still doesn't move really fast, but it's not bad. So, but there you have the sweeping ability. So you hold the button down to get where you want, either direction. And see right there, I held it down too long. So the only way I can get around that is actually to reboot the Arduino so the xbee boots back up again. That's one of the issues I'm finding here. I'm going to experiment that a little bit more, increase the baud rate of the xbee and see what happens. All right, so because we know that the speed is a little bit of an issue here, what we're going to do is I'm going to increase the time again, but I'm going to do this a little differently. Rather than going one at a time, I'm going to go by 5 at a time. So let's just just increase this to up and down by 5. Make sure that syntax works. It does. All right, so I'm going to change re-upload this. And that's done. They put the pins back. There should be an easier way to do these than taking these pins off and on all the time. And let's see what happens. So there you go. You see it works a little bit better. I could probably actually increase the times a little bit more, but it's something you can play with back and forth. So let me go show you what I just did to get it to work a little bit better, like that. Over at the code. So what I did is I, instead of doing the ++1 right here, I made the current value plus equal 5 and current value minus equal 5. So it's going 5 at a time every 50 milliseconds. So that makes it a little bit more, it's still jumpy, so you can tune that back and forth. But that gives you a pretty good idea of what you can use an Arduino for. I mean, you can do all kinds of things with Arduinos. I have so many things I want to do with these things. I just don't have time to do it all. That's part of the problem. So that was pretty much what I wanted to cover this week while I'm out. So get you something to play with, and you can think of all the other things you can do with it. I've seen things. Actually, the book I'm going to that I recommended last week. It's on the bottom. In the show notes, I put it in this week's show notes as well. And then there's projects like making a doorbell, which it'd be like a wireless doorbell. So it really could be, a doorbell. Like I mentioned last week, the xbees that I'm running do not have external antennas on them. I think they say 100 feet, but I can't say I've tested that. But I'm sure that's like clear open space because the antenna on them is actually really small. If you looked at them last week real close. So, but that is pretty much it for this week. If you are watching this via iTunes, definitely appreciate you going out and putting a rating out there and a comment. That helps us a lot to get found in iTunes. If you're watching us on YouTube, if you can go out and click the button that says a thumbs up on there, the like, you can share it with your friends. Comments there too. All this stuff helps us get found. We are a very new show and looking to increase our community. So any help you can give us with that is greatly appreciated. All of the things we talked about on every show every week are out at techzen.tv. You can also go to letsmakeit.tv. It takes you to the same space, right to the right show page. Every show has notes out there and code examples, and you can download the videos there as well. We have plenty of ways to get in contact with us. We'd love to hear from you. I've been getting emails from people, and I'm slow getting back, but I do get back. But I love having the comments. It definitely gives encouragement to keep on going. So, like questions, future show ideas, things like that all comes in. If you have a project you've done with the Arduino or anything like this, the Raspberry Pi or whatever, it doesn't matter. We'd love to see it. And create a video for us, put it up on YouTube, and we'll play it on our show. We'd love to do that. I think I mentioned at the beginning of the show, maybe I didn't. We are a member now of the Tech Podcast group, or I'll call it a network. I think it's the consoles a network. I call it a network. It's a network of a bunch of tech people like us putting their shows out there. But it's techpodcast.com. Go check them out. You can get us on Roku now under our techzen.tv app or the techpodcast.app or app too. They got their own app as well. You can download us on iTunes. You can watch us on YouTube. We're on Blackberries. We're on Windows Mobile and Zunes even, although the Zune's not video, I don't think. If I remember correctly. Like I said, we're pretty much everywhere. We're even on Stitcher. With Stitcher's audio only. If you're listening on audio, this probably wasn't as valuable to you as if it is on video. But if you are listening to us on Stitcher, which we are on there, you can go to the show notes or go to the show page, techzen.tv, and actually watch it when you get somewhere. Or you go to YouTube, and it's Techzen as well on YouTube, and watch it on YouTube, wherever. But we definitely appreciate that. Definitely appreciate the comments. We normally record this show live every Tuesday night at 7 p.m., although this week, like I said, I am not here. I am out somewhere where hopefully it's warmer than where I am here right now. And this show has been released by my wife. Thank you, Michelle, for letting it go. And I will be back next week, and we'll do another live at 7 p.m. on Tuesday nights. Just go to techzen.tv. We have a chat room. It's right up there. Of course, since I'm pre-recording this, nobody knows I'm even in here unless you're watching the stream live as I'm doing this. So we'll see you all next week on Let's Make It. For show notes for this show, contacts, and more, go to the techzen.tv website where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the techzen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo, and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks, like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku. You can even find us on your Zune.